All right, on problem 87, we're taking a look at some roots, and we want to find the quadratic that these roots come from. So for the first couple, we're going to have a quadratic because there's only two roots. However, the last couple, we need to figure out the quadratic first from these, and then we're going to get a cubic because we have a third root. So there are three different methods we can use, and I'm actually going to go through and show all three of them. You can do whatever method you like, but I'm going to go through and show all three different methods here. So the first method is using the sum and the product. So I'm going to do problem A using sum and product. So if I would add these things together, the positive I and negative I cancel each other out, and my sum is going to be a -6. If I do the product, I'm going to multiply them out, and I have a -3 in I and a -3 and a negative I. Now when I go through and fill this out, this is going to be a positive 3I and then a negative I squared. These make 0, and this box right here is a negative I squared, which is a negative, and then I squared is a -1. So that box equals a +1. So then my product, I add those together, my product ends up being 10. So with sum and product, if I want to find the quadratic that it comes from, I have x squared. The opposite of this one, that is my b value, so plus 6x. And then the product is my c value, plus 10. So for problem A, that is the equation there in blue, x squared plus 6x plus 10. For problem B, I'm going to go through and do a different technique. So if I have a root that is 5 plus square root of 3, if it's a root, that means x equals that. So if I think about getting this back to equaling 0, x minus 5 minus square root of 3, so I subtracted the 5 and square root of 3 from both sides, equals 0. This would now be set up like zero product property. So basically I'm using zero product property in reverse, but this then is my factor. So then doing the other thing, or the other root, x equals 5 minus the square root of 3. Now I would subtract the 5, but add the square root of 3 to both sides. So I have my other factor. What I can do with those two factors now is make a 3 by 3 generic rectangle. And I'm going to put x minus 5 and a negative square root of 3 on one side. And I'm going to put x minus 5 and a plus square root of 3 on the other side. And now I'm going to go through and multiply all of them out. Positive 25 at that one. Positive 15 square roots of 3. There are going to be several of these that are going to cancel each other out. And you can see that one and that one right there will make a 0. I then also have, this one should just be a positive 5, not 15. And this one right here is a negative 5 square root of 3. So again, these will also cancel out. And then the top box here is going to end up being a negative 3. Square root of 3 times square root of 3 is 3. And then I also have that negative. So make a 0, make a 0. So now I'm going to have x squared. I have the negative 10x's. And then I have 22. So you could use sum and product like I did for problem A, or make your 3 by 3 generic rectangle. Again, to set up that 3 by 3 generic rectangle, I used the zero product property sort of in reverse to get my factors. Okay. So now, problem C. Hold on one second. So now when I take a look at the problem C, the third one here, I'm going to work with these two roots first and use whatever method I want to use to figure out what quadratic that comes from. And then I'm also going to use this one after that. So the third technique is, again, to say that if x equals that root, what do I need to do in order to kind of use completing the square backwards? So what I'm going to do right now is I'm going to square both sides, and I get x squared equals 7. And now when I subtract that to get it equal to 0, I get x squared minus 7 equals 0. That is my factor. So for the other one, if I have x squared equals negative square root of 7, oops, not x squared, just x equals square root of 7. Now when I square both sides, you will see that I actually still get the exact same one of positive 7, because if I take a negative square root of 7 times a negative square root of 7, it will become positive. Two negatives make a positive. So the reason why I get the same answer here is because when I start with this and I go to this step and take the square root, I would get the plus and minus of both sides. That's how I get my two solutions. So for this particular case, I only need to do one of them. So this is now my quadratic factor. From negative 2, if x equals a negative 2, that means that x plus 2 equals 0, and x plus 2 is my other factor. So now to get the polynomial, I need to multiply those two things together. So I'm going to go through and make a generic rectangle with x squared minus 7 and x plus 2. So now I'm going to get an x cubed, a negative 7x, 2x squared, and negative 14. I do not have any like terms on this one, but my equation is now going to be x cubed plus 2x squared minus 7x and minus 14. There's my cubic in standard form. So now problem D, I'm going to go through and do the same thing. I'm going to start with this, x equals negative 3 plus I, and I'm going to again use the same technique I did for C. I'm going to add 3 to both sides. X plus 3 equals I, and now I'm going to square both sides. So when I square x plus 3, I'm going to get x squared plus 6x plus 9. And on the other side, when I square I get a negative 1. Getting this back to 0 is x squared plus 6x plus 10 equals 0. That is my quadratic factor from these two roots. Again, I get both of them from this. Both roots come from this one, so I do not have to do the same thing twice. Now, my other factor is going to come from the 4. So x equals 4. I subtract that, and I get x minus 4 equals 0. So now what I need to do is take my two factors that I have and, again, multiply them together. So now on one side, I'm going to have my x minus 4, and on the other side, I'm going to have my x squared, 6x, and 10. So multiply all these together. This one will have like terms. So I'm going to end up getting my x cubed. From these right here, I'm going to get 2x squared, negative 14x, and negative 40. There we are.